chemistry class. We are learning about separation techniques, and some of the separation techniques we have completed, and now today's class also we are going to learn some separation techniques. You have learned about some of the separation techniques like separating, funnel, filtration, winnowing, hand picking, etc. In today's class, the left one, froth flotation, we have learned first. We can learn first, okay? Froth flotation means something related to floating. In froth flotation, what you have to take is, you can use this froth flotation for separating ores. Here we can take pine oil, water. What are the contents? Pine oil, water, then the ore, and we have to apply compressed air here. You have to apply the air through this compressor. What happens means, the ore contains many mud. This mud will be too weight. When it is absorbing this water, it will gain weight and it will settle down in the bottom. This mud. Then pine oil will form some froth. That is some lighter materials like, and ore also containing some other lighter materials. This froth form will take the lighter materials with this and it will form like a floating in this liquid. So now you can separate this unwanted mud and the required ore. You have to collect it from the top. So by applying compressed air, what happens? This pine oil will form some froth. This froth will take all the ore contents and it will come to the top and it will float in the top. The weight, mud, etc. will remain in the bottom. In this way, using froth flotation, you can perform separation. This froth flotation is most commonly used in ores, separating ores. Next one is separating funnel. We have learned in the last class. Next one is distillation. Distillation is nothing but, here we have a special apparatus called distillation flask. Usually this distillation is helpful to separate immiscible liquids which has varying boiling point. For example, consider water has boiling point 100 degree and some other liquid, oil has boiling point, some other lower or higher, consider 60 or 70. When two miscible liquids, oil you cannot take because oil and water are immiscible. Two miscible liquids you have to take, and when you add these two miscible liquids in this distillation flask, this is purely depending upon the boiling point. Listen here, you add this mixture here. Consider one liquid has boiling point 100 degrees Celsius and other has boiling point 80 degree Celsius. So, which liquid will boil first? Which liquid will turn into, you know that evaporation is nothing but changing from liquid to gaseous state when it is attaining at particular boiling point. So, this will boil first or this will boil first? Yeah. We all know the liquid with less boiling point will boil first. It will start boiling and it will reach here. Here what happens means, here is a tube. This liquid with the less boiling point, first it will boil and it will travel through this tube. Here is a condenser. Condenser is used to cool down. You can have a thermometer here to observe the temperature. When this gas reaches this condenser section, the function of this condenser is to cool the gas or liquid flowing through that particular condenser. So when this vapor reaches this condenser region, this is condenser. The tube will be in the center. Out of that we will be having the condenser. When this liquid is reaching this condenser region, it will get cool and it will change into liquid, and you can collect this liquid here in this flask. Now you have collected one liquid, and other liquid with the higher boiling point will remain in the distillation flask. This is nothing but distillation flask. This is a stand, this is just a conical flask, this is condenser. Clear about what is distillation? And the next one is fractional distillation. What is the difference between this distillation and fractional distillation? Distillation and fractional distillation. In distillation, we have seen that we can separate two miscible liquids with varying boiling points. The boiling point should vary. Both should have different boiling points. But in fractional distillation, what we can do is the liquids, miscible liquids like not much variation in boiling point, that may be 100, 102. Like this, very close boiling point liquids can be separated using this fractional distillation. The difference between distillation and fractional distillation is, here you will be having a fractional column. Same like distillation, but in addition to distillation, you will be having a fractional column. What is the function of this fractional column is? This column, lower portion will be having higher boiling point, and this upper portion will be having lower boiling point. Then the procedure is same as that. You have to take the liquids here, then you have to apply heat using Bunsen burner. When you heat this vapors will move. First what will move? The liquid with lower boiling point will evaporate, and as this column has lower boiling point in the top, this will move to the top, and this setup will go here. From here you have to collect it using condenser. Just you have to condense it and collect it in this conical flask. Once again listen. First what you have to do is, you have to heat this liquid. These two liquids can be with the same boiling points. That is, almost similar boiling point liquids can be separated using this fractional distillation method. The lower boiling point is collected in the top of this fractional column, and again it is given to this tube. When it is reaching this condenser, it is cooled and it is collected as water drops or liquids. And the liquid with higher boiling point will stay in the bottom, and when you stop this cooling, it will automatically collected in this distillation flask. This is all about fractional distillation. I hope you are all clear about flotation, distillation and fractional distillation. Then the next one is crystallization. What do you know about crystallization? In last grade you have learned grade 7 you have, grade 6 you have. What do you mean by crystallization? Crystallization means at the end of the process, crystals will be formed. This is nothing but crystallization. How these crystals are formed? By applying heat, right? Crystallization means, listen, when you have a solution, but the solution will be formed by a solid mixture, that is solid. Sugar is a solid, By mixing sugar you can form the solution. Now the solution is here. Now you have to warm the solution, that is heat up this solution. What you should do is you have to add more solute and you have to heat up this solution. It should be heated until there will be no chance to add further the solid. Until that you have to warm up, and now you have to allow this to cool. Without disturbing, you keep this. When this is the solution is slowly cooling, the solid crystals developed in this will solid, that is sugar dissolved in this, will develop as small crystals inside this mixture, so that now you can separate this solid crystals from this solution. This is nothing but crystallization. Then about centrifugation. About centrifugation, what is centrifugation? Centrifugation is following a principle and it is carried out in a apparatus called centrifuge. What happens means, consider small suspended particles are in some liquids. What you have to do is, you just tie that, have it in the bottle, just tie that bottle and rotate it like this in a fast manner. What happens means, at a particular time, all these suspended particles, small particles suspended in this liquid will slowly settle down in the bottom of this bottle, and the liquid will be floating in the up of the bottle. For example, in laboratories they use this. See this? This is a blood sample. This is the machine used for centrifugation. It is called centrifuge. They are keeping this blood sample inside this and they are allowing this machine to operate. What happens means, just a rotation is taking place, and in this you see blood is separated in the bottom and the remaining unwanted particles are separated in the top. Now what you have to do is, as already we have learned, sedimentation and decantation. Can you remember this decantation process? Have a beaker like this, have a stirrer like this, slowly pour the mixture. The liquid will be thrown here and the remaining you collect in the glass. If you want, you can go back and see the sedimentation and decantation pictures. Then first you have to apply centrifugation, and then you can separate these two separated liquids using centrifugation, using this decantation method. This is nothing but centrifugation. Then the next one is, the last one is chromatography. You are familiar with this word. In the grade 7 also you have the same heading, same diagram, same explanation. Anybody can remember this? Shall we give it as a homework? Can you? Or you want me to teach? Let's see. Chromatography. About chromatography, and the example given is paper chromatography. I hope you remember. You have to take a paper, then you have to drop ink drop in that paper. When you put it in the inside that solvent, this inside the liquid started traveling through the paper. When it reaches the ink, it takes the color pigments also. At a particular height, it will be in one color. When it is reaching higher heights, it will give different colors. This is nothing but paper chromatography. We can see what is chromatography. Once again, chromatography has two phases, stationary phase and mobile phase. The best example for chromatography is paper chromatography. Have a solvent, you will have a filter paper in this. What you should do is, you have to drop a drop of ink you should put in this paper. The chromatography works on the principle of absorption capacity. Consider you have a paper, you put it inside water, the water will be absorbed by the paper. You put cloth, it will be absorbed, water will be absorbed by the cloth, but the rate of absorption varies. paper absorbs in a particular speed and cloth absorbs in some other speed. So depending upon the speed or rate of absorption, the elements can be separated. Now you have dropped this ink. What happens means, when you put this paper in the solvent, the water started moving into this filter paper. When this water is reaching this ink point, this ink will be having many constituents. The constituents which are more affected by, more absorbed by the water will move faster and it will be in the top. But some constituents will be there which will be less absorbed by the water. The absorption capacity of that constituents or the traveling capacity in water will be less. The less affinity, that is, they have less affinity to liquid. The constituents having higher affinity to liquid, it will move faster and go top. And depending upon the affinity, the constituents will be separated. Actually, this is the application in color writing. This is already have learned in your grade 7. Just I have revised. There are some applications for this or uses of this paper chromatography. They are used to identify the constituents. As this are separated, you can identify what are the constituents. Then separation of amino acids it is used. Then determination of hormones and drugs in the side of medicine it is used. Then the last heading is combination of separation techniques. When you consider many substances in the same mixture like sugar, salt, oil, water, so this can be separated using combining some techniques. First you go for separating sand. How you can separate sand? When you put this mixture in water, the sand alone will not dissolve, remaining substances will dissolve. So now by filtering you can take this sand out. Next you can go for next method. Oil is there. Using separating funnel you can get the oil separately. So when you consider more than one constituents or 3, more 4, 5, 6 constituents in a mixture, you can use many methods in a sequential order. You should have this. First you have to use this method and separate this. First, then you have to use this method and separate this. Like that you have a technique. For this you have to use this, for this you have to use this. Then you can separate all the constituents by combining more than one separation techniques. So by this we are ending this unit. I hope you all understood, and this is our exam portion. That is froth flotation, then starting from distillation to chromatography, and last this combining the separation techniques. I hope you all understood. We can meet in the next class. Thank you, students.